Hi, what I want to do in this video is show you how to use the Excel functions associated with continuous probability. And sort of walk you through that. And not only just show you how to do it, but also to show you how do you make a decision which one to use, and what are you looking for in this process? How do you start problem solving when you can actually use these functions? And that's what I'm hoping to spend some time on this morning. Um, let's start them from here. This is about particularly the z functions, the normal and z functions. These are for continuous probability distributions. Last week, what we worked on were discrete probability distributions. This week, it's continuous probability distributions, where your variables literally, at least conceptually, there's no, there can always be another number between any two numbers. That's the continuous probability distribution. I'm going to introduce the different functions and which functions for which givens in a problem. Some key concepts here is, okay, it's obvious, I don't need to say that, but here are the 5 functions that are in Excel that you would be using this week. Norm.dist, norm.s.dist, norm.invert, norm.s.invert, and standardized. Now, the simple of those is the standardized one. But there's a chart in your stuff this week. And this chart's really important. Let me repeat. This chart is important in problem solving. When I give you a problem, the first question that you should be asking yourself is, okay, is this problem Steve giving me? Is he giving me a standardized distribution or a raw number distribution? Which one is it? If it's a raw number distribution, that is, you got 273.5 and 161.2 or something, that's clearly not a standardized distribution. It's a raw score distribution, and that means you use either this one or this one or this one. There are 3 different distributions you'd use for it. If you look at the distribution and what you have is, I tell you, it's a z-score distribution, then you want, it's like, well, it's got to be this one or it's got to be this one. Those are the only 2 ones associated with that. That's the first thing. So step 1 is raw scores or standardized scores. And that's the question. Now, I can tell you, standardized scores, if you take like IQ scores are standardized. You take an IQ test and you get your raw score might be that you got 37 correct out of 50. What'll happen when they report your IQ to you, they'll say you have an IQ of 110, which means they've standardized it. The IQs are typically given with a mean of 100 and a standard deviation of 10 or 15, depending on the test. That's most common. That's a standardized distribution. It's been standardized away from the raw scores. So first question is raw scores or standardized scores? Really crucial first question. Second thing is, what do I ask for? Do I say, find the score that with an IQ scores, standardized, find the score which is associated with like 50% of people or 75% of people score less than that. Well, in that case, what I'm saying, you've got to notice you have a standardized distribution, and I'm looking for a score. These two, norm.dist and norm.s.dist, they provide a probability as opposed to a score. These two give you scores, these two give you probabilities. This one down here is the simplest of all of them. If I say, here's a distribution that's, of a test scores that are on the last 25-point test. Tell me what the z-score is associated with 75% of people score less than that. Well, you could do this thing here and you could take that, you just get a distribution and find it. Or if I give me, you have a 25-point test and you got 18 correct on the 20 out of 25. What's the z-score associated with that? Well, it's a distribution. You find the z-score, then you got it. But what you're going to start with is saying, first of all, do I have do I have a raw score distribution or do I have a standard size score distribution? And then the second piece is, do I want? Is Steve asking me for a score, or is he asking me with probabilities? Now, here's a tricky one. I'm going to ask you at some point is, what's this? With a, well, I gave you already on the other video I did. If what percent of people are likely to fall between scores of plus 32 to plus 62? Well, if you got plus 32 plus 62, you're talking about a raw score distribution. What you may need to do first is find out what's the score associated with a certain probability. Or, you have a raw score distribution. You want to know what's the probability of something. Well, I'm looking here ultimately. So I start here and go to this one here and have to do a couple of different computations with that. But this is where you start. This chart is where you start with every one of the problems this week. These are the 4 tests that are to be done. And of these, standardized is the simplest one. It just gives you a standardized score from a raw score every time. These 4, norm.invert, norm.s.invert, norm.dist, norm.s.dist, those are the 4 big tools you're going to be using this week. I'll show you some on how to use those things. Interesting things about these functions, they don't require you to have a data set in Excel. So I can tell you some things, but you don't have to have the distributions there in front of you. And they give you, these are dialog boxes, typically. Standardized, I mentioned that. That's the 5th of them. This figures out z-scores when you know a score, the mean, and the standard deviation. This is what the standardized dialog box looks like. And what you do with it is you put in your mean, standard deviation, your x, which is the score you want to find the z-score from, put in the mean and standard deviation, and it'll tell you what it is. For instance, if you have a score of 634 on a test with a mean of 500 and standard deviation of 100, what's the z-score associated with your 634? You can try that right now. I mean, I'm sure you really could try that. But if you had not to walk you through, you get a dialog box that's like this. You put in 634, that's your score. The mean's 500, standard deviation is 100, and it right away tells you z-score is 1.34. Very straightforward. That one's the easiest of all of them to use. Let me go back to the problem here. Now again, just so you have a score of 634 on a test with a mean of 500 and standard deviation of 100. What's the score associated with your score? What's the z-score associated with it? Now, if you look at that, you kind of go on, you have a mean of 500 and a standard deviation of 100. That could well be a standardized distribution. But you can use standardized with any distribution, so it doesn't really matter in this case. Now, go on a bit. Norm.dist. What's norm.dist? Now, as you can see, I'm sort of walking through what is normally is a PowerPoint distribution. Actually, what I should be doing here is I should be going back to the piece here. Norm.dist, you start off norm.s.dis. The S in it tells you you're working as a standardized distribution. What you do here is you put in some z-score, and then you put it here for either true or false in here to tell you whether you want the cumulative or the standard or the point probability for that distribution. For instance, I put in 1.4 as a z-score here, and then I put in true. What true does is true gives me a cumulative distribution. And it tells you that in this case that 91.924 or roughly 92% of the scores fall at or below a score of 1.4. Now here's a trick this week, and I mentioned this in my the written materials, but you are listening, you think about this carefully. If I ask you a problem and I say, what's the probability that up to keywords, up to, or at least, or at most, if I ask you those, if the language has that kind of stuff with it, you're looking for a cumulative distribution. If I say, what's the probability that you will get exactly a score of, then you're looking at a point distribution. So the way you're going to decide here whether this is a true or a false is you read my language. And when I'm using language like at least, up to, no more than, that tells you it's a cumulative, or you put true in. In this case, the probability of getting up to a z-score of 1.4 is 92%. What if I said, what's the probability of getting a z-score of exactly 1.4? You still use norm.s.dis. You put in 1.4, but here you put in false rather than true. And the probability of getting z-score of exactly 1.4 is about 0.15. It's 1.49727466, or approximately 0.15. Now you think about that. Just think about this for a second. On the one thing I said, what's the probability of getting a score up to a z-score of 1.4? That means 1.4, anything up to that point, versus getting exactly 1.4, which is just a specific point. As you might imagine, if you think about that, getting the specific point is a lower probability than getting that score or any score up to that score. So getting the point probability of 0.15 roughly here is smaller than the last one, which was the cumulative probability, which is about 92%. I had those were the norm.dis functions, the norm.inverse functions. In this case, you start with a probability and you want a score. And with norm.s.inverse, you see the S here, that means you're looking with a standardized distribution. If I say, what's the score of what's the score associated with a 9% probability? And I look at what, the simple thing to do is you put in 0.09 and it jumps up here. It says negative 1.34075. And what this does, the inverse functions give you scores that you put in the probability and you get a score. The norm.dis functions, you put in a score and you get a probability. And that's the thing earlier I said is you start off raw or standardized, then decide what's he giving me and what's he asking for. If he's asking for a score, you're going to want to use the inverse functions. If you're wanting to get a probability, then you'd use the dist functions. I'm not going to talk about that. You can read it. We've worked with the norm.s.dist and norm.s.invert. Let me just show you norm.dist functions. Now this one is used with raw scores again. So what happens here is you put in your raw score here at the x, you put in the mean of that raw score, you put the standard deviation, and you tell you whether you want a raw or standardized, whether you want cumulative or point probabilities. For instance, I could put in 634 here as my raw score. This is the score I got. The mean of 500, standard deviation of 100. If I'm saying what's the probability of getting a score up to 634, it tells me down here it's about 91%. You get the probability, the dist function, the distribution. You get probability scores. Mm-hmm. Go back to the question here. It doesn't come up. I talked about this problem earlier. Here's the norm.inverse function. This is the one again where you start the inverse functions. You start with a probability, it's going to give you a score. Nope, I'm going to stop there. Those are the 5 functions here. Those are the 5 Excel functions. They're all under the probability stat bar in Excel. Go back to first question is raw data or standardized data. If it's raw data, well, some of the functions can be used with any kind of distribution, raw scores or standardized scores. Some of them, when they have the S in the center, can only be used with standardized distributions. So you either use one for anyone or those that are standardized functions, standardized distributions. And then the question is, am I giving you scores and asking for probabilities, or am I giving you probabilities and asking for scores? That's an important distinction here. And it's worth your time before you get started doing any of the problems to stop and say, what's it giving me and what's he asking for here? And walk through that and print off that little 5-thing chart and so you walk through it and say, okay, this is the functionality they're using. And then you got to figure out how to use it. Now, let me tell you, if I'm asking for something that says, what's the probability, what percent, or and the probability is going to be the same as percent here, what percent of scores fall between X and, between 23 and 47. Well, when I do that kind of thing, which almost always going to be used is a cumulative probability, and you find the probability of something being less than 47, and you find the probability of something being less than 23, and you take the first one and you subtract the second one, because what that does is it gets rid of the bottom part of it, and it tells you, okay, here's the probability between these 2 points. It's a way of thinking about probability. Remember, with a normal probability, standard normal curve, the total area under the curve is equal to 1. That's the probability of everything happening. And then you're looking at what's the probability of certain kinds of things, that standardized normal curve happening. And on the one hand, it could be the probability between 2 points, or it's to the left at some point. You cannot figure with Excel the probability to the right. You can't do it directly. You can figure the probability to the left and subtract that from 1, and that would tell you the probability to the right. But Excel will only give you directly the probability or area under the curve to the left of that point. What you have to figure out is like, was he asking me for the percent that are greater than that, or the percent that are less than that? Because the left is always left than that. If I'm asking you for the probability of something greater than a given score, then what you got to do is you got to figure out, okay, the probability less than that is this. Subtract that from 1, and that'll give me the percent that are greater than this. It's a funny way of thinking about some stuff, but there's a real logic within it. And those 4 different tests, I'm excluding the standardized test here because that's a really simple thing to do in some ways. It just gives you z-scores when you've got some scores. The norm.invert and norm.dis tells you the scores or probabilities. Norm.s.invert and norm.s.dis tells you the same things with standardized distributions. So you're trying to pick out which of these things, which of these 4 tests are the ones you're looking for. Maybe 5 tests of standardized also. And then you got to figure out how to combine those things. Most of the problems I give you are not simply what's the number to the left of the thing. It's not that simple. Usually it's what's the percent between this point and this point, or what percent is greater than this point. And it causes you to actually have to do some work with that. And that's what this week is about. Ask questions. I'll be happy to help you work with them.